Next. Okay. Then now. So we started index. You understood the purpose. Okay, na? What the main purpose of index? Now, suppose this is our table. In this, salaries are there. One salary 5,000. One is 1,000. Okay. One is 3,000. One is 2,000. Okay. One is 4,000. One is 1,500. Another one 3,000. Another one 2,500. Like the salaries are like this. Total how many? 8. You created index on salary. When you create the index on salary, one structure is created something like this 3,000. So this is the root node. I'm taking the root node. But this root and intermediate nodes are based on some algorithm. Okay. Then so 2,000. Left side of 2,000. What comes? Left side to 2,000. 1,000 star. Star means address. Leaf nodes contains what? Leaf node contains what? Salary plus address. So salary is 1,000. Address of the record whose salary equal to 1,000. Next one 1,500 star. So this is salary plus address of the record whose salary is 1,500. What is the next one? 2,000 star. Salary 2,000. Address of the record whose salary is 2,000. This one. Next one. Right side to 2,000. Then 2,500 star. 3,000 star comma star. Why 2 stars? 3,002 stars. Why 2 stars? Why 2 stars? 2 salaries, boss. There are 2 employees, 3,000. What is star is address, record address. How many records are there with salary 3,000? 2 records, then 2 addresses. Maybe this is first record address. Maybe this is second record address. There are 2 records with salary 3,000. That's why 2 addresses. Next one. Let's see. Right side. 4,000. 4,000. 4,000 left side. Then 4,000 left side. What? Not general. Example is there. You tell me exact answer. That's all. Why general answers? 4,000 star. That's all. What is there? Next. Right side. 4,000 right side. 5,000 star. That's all. How many records? 8 records. Here what? 3 plus 3. 6 plus 2. 8. How many addresses are there? 8 addresses. 8 records are there. 8 addresses. That's all. Okay, now? Then. So this is created. This is what, sir? Created. But here I have not taken like lines. Left side, right side lines. Okay, then. Understood? Then. So maybe like this. Maybe like this. This is left side. This is right side. This is left side. This is right side. Suppose, for example, then this is leaf node. This is leaf node. This is also leaf node. This is leaf node. This is root node. This is intermediate nodes. So the tree will be created something like this. Plus between these leaf nodes, there is a what? Between the leaf nodes, there is a what? Interlinks. One leaf node is interlinked to another one. The leaf nodes are interlinked. Here also the leaf nodes are interlinked. Okay, na? This is the what, sir? Structure of the bee tree. The tree is created something like this. Okay, then. So then tell me when SQL server will use this? SQL server, when SQL server will use this? When it will use this index? It will use this index whenever you submit a query. In that query where condition based on salary, then it will use index. You submit a query. In that query where condition based on salary, that means your set is based on salary. Then that case it go to this index. Understood? Then. So let's see. Suppose now I'll remove this. Then. Now let's see. Okay, na? Then. See, when user submits a query, when user submits a query to SQL server, it uses what? It uses the following methods to access the data. When you submit a query to SQL server, it uses following methods to access the data. There are two methods. One method is called table scan. One method is called index scan. One is called table scan. One is called index scan. One is table, another one index. What is table scan? So in table scan, SQL server scans the entire table. In table scan, SQL server scans what's that? Entire table. Okay. In table scan, SQL server scans what? Entire table, one by one row. That is row by row. That is what's it? Row by row to find what's it? Your where condition selects are from EMP where salary equal to. Okay, na? Then, so if it goes, if it is in table scan, what it does? Table scan means go to the table, going to the table. Then in table scan, SQL server scans entire table. That is row by row to find required, whatever the required row. So to find the required record, what it does, row by row, first row, second row, third row, fourth row, fifth row, like this. Then, okay, when it goes to the table, if index is not available, then it go to the table. If index is available, maybe it goes to index. In index scan, SQL server scans what? Okay, na? SQL server scans on average in index scan, on average, SQL server scans half of the table. SQL server scans what's it? Half of the table to find required record. Whatever the record you're asking, to find that record, SQL server scans only half, either left side or right side. It doesn't need to scan complete table. Yes or no? Understood or not? Then. So my query is this. What is my query? Select start from EMP where salary equal to 3000. Then tell me what it does. Suppose assume index is not there. Then if index is not there, then table, it go to the table, go to the first record. Salary is what? 5000. Condition false. Second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one. It go to each and every row, checks condition true or false. How many rows it compares? 8 rows. And how many comparisons? 8 comparisons. Okay. Suppose assume index is available. If index is available, then it goes to index. It go to the index. What is the given value? 3000. 3000, 3000 is compared. Then go to 3000, 3000 is compared. Then go to left side. 3000, 3000 is compared. Then go to left side. 3000, 2000 is compared. Pass. Given value 3000. If it is equal or less than left side, greater than, go to right side. 3000 equal to 3000, then left side. Next 3000 compared with 2000. 3000 is greater than 3000 is greater than 2000. Then go to right side. Then right side, there is a leaf node. Now you come to the leaf node. So after coming to the leaf node, then it will check any salary is there 3000. Sir, this is 2500. Condition false. This is what? 3000. Condition true. Then take this one. Addresses. So there is a 3000. Then take this addresses. Go to the table. Select the records from the table. Once it knows the address, directly go to that address. Select the row. How many comparisons here? 1, 2, 3, 4. In 4 comparisons, you are able to locate salary equal to 3000. If it go to table, how many comparisons? 8. If it is index, how many? 4. That means the number of comparisons reduced to half. Performance is improved. That's all. What I'm saying is for any given value, either it will set left side or it will set right side. Because maybe it is equal or maybe it is less than, maybe it is greater than. Either it goes to left side or it goes to right side. That means it doesn't set complete table, only half of the table. Okay, then suppose for this query, it will use what's that? Index. Because index is available, index can. Suppose my query is this: select star from EMP where salary greater than or equal to 3000. Then tell me what? Salary greater than or equal to 3000. You're asking for salary greater than or equal to 3000. Then what is the given value? 3000. 3000, 3000 is compared. Then go to 3000. 3000 is compared. Then go to not right side, boss. Once again, listen. Don't apply this condition at root and intermediate levels. Apply this condition only at leaf level. Apply this condition at only leaf level. Root and intermediate level, only this, take this value, compare this value. Don't apply this condition. Because where are the salaries? Salaries are there in only leaf nodes. Apply this condition only at leaf level. So don't apply this condition at root and intermediate levels. Then in intermediate, root and intermediate level, then consider only this value. What is this value? 3000. 3000, 3000 is compared. Then equal. Then go to left side. Go to left side. 3000. Given value 3000. Root node is 3000. Equal. Then go to left side. Next one. 3000. 3000, 2000 is compared. 3000 is greater than 2000. Then go to right side. Go to the right side. Now it is come to the leaf node. Now it will apply the condition. So tell me 2500 is greater than or equal to 3000? No, condition false. 3000 is greater than or equal to 3000? Yes, condition true. Then take this one, addresses. Take this addresses. It select this one. And also select the nodes which are right side to 3000. Also select the nodes which are right side to 3000. Because the nodes which are right side to 3000 are greater than 3000. Because you're asking for salary greater than or equal to 3000. So the nodes which are right side to 3000 are greater than 3000. You see the tree is in such a way that what is the structure left to right, the values are in ascending order. So it select 3000, also select the nodes which are right side to 3000. How it go to the right side? How it go to the right side? Now just now I said what I said, this leaf nodes are interlinked. Okay, na? Then set B tree index in SQL. Okay, then now 1 second. You see this? Yesterday I had taken this. So then okay, na? Then see, you see that leaf nodes are what's that? There is a interlink between the leaf nodes. Okay, na? One is linked to another one. This node is linked to previous and linked to the next. Okay, then now let's see. So once it comes to 3000, then 3000 is selected, and also select the nodes which are right side to 3000. The nodes which are right side to 3000 are what? Greater than 3000, because you're asking for greater than or equal to 3000. And how it go to the right side? This one with the help of this interlinks. Okay, then. So for this query also, what it uses? What it uses? Index scan. Next one. Suppose select star from what's that? EMP. Where salary less than or equal to 3000. Then what? Select star from EMP, salary less than or equal to 3000. Then uh, say how it 3000. 3000 is compared. Then go to left side. 3000 2000 is compared. Go to my left side boss. 3000 given value 3000. 3000 2000 is compared. Then go to right side. 3000 is greater than 2000 na. Then go to right side. Next one, you come to the leaf node. So any leaf node is there, salary less than or equal to 3000. Yes, this is selected. Yes, this is selected. Yes, and it also select the nodes which are left side to 3000. The nodes which are left side to 3000 are what? Less than 3000, because you're asking for less than or equal to 3000. This is selected, and it also select the nodes left side to 3000. How it go to the left side? How it go to the left side? By using this interlinks. Understood? Yeah. So that means not only this query, these three queries will benefit from index. Not only equal to, greater than, less than conditions also will take the advantage of index. Okay, then my query is this. Select what's it? Select star from EMP. Select star from EMP where e name equals to Blake. Then so then tell me, for this query, is it uses index? Then suppose see, for this query, will it use index? For this query, will it use index? Boss, index based on salary. All these are what, sir? Salary. Where condition based on e-name. For this query, how it will use index? It cannot use this index. I'm asking about this index. Sir, for this query, will it use that index? No. Then it will use table scan. Why? Because index created on what was salary, where condition based on e-name. So it will not use index. This is my query. Select start from what? EMP. Then select start from EMP. For this query also, what? It uses what, sir? Table scan. Because you want all the data, na? You're asking for all the data. When you want all the data, then why index is required? So textbook is there. You want to read the complete textbook. Is index is useful? You want to read the complete textbook. Index is useful? No. When index is useful? When you want to read particular topic. You're also saying you want to read the complete table. Index is not useful. You want specific row. Index is useful. Understood? And that's all. So this is about creating the index, how index works. Okay, then how index improve the performance. Next. So if you create index on multiple, then it is called composite index. Index created on what? Multiple columns, then it is called what? Composite index. Okay, then so it created on multiple column, then it is called composite index. Example, I2 on EMP, then so create index I2 on EMP brackets what? Department number comma job. Why you are creating index on two fields? Because where condition is based on two fields. Department number equals to 20, job equals to clerk. Department number equal to 20, job equals to clerk. So what this is? So this query is running slow. I want to improve the performance of this. Then create index on this. Your where condition based on how many fields? Two fields. So create index on two fields. Okay, then. Now what this is called? This is called what? Composite index. DB 6 PM. Then. Okay, now? Then. Understood? Now. So maybe index is created like this 20. Next one, what's that? 10. Okay, now? Then 10th, what's that? Clerk. 10th, what? Manager. 20, what's that? Analyst. Star comma star. 20, what? Clerk star comma star. So this is 10 clerk star. Okay. 20, 10 manager star. Next one. This is 20. Okay. Then next. So right side of 20 is what? 30. 30 left side is what? 30 clerk star. 30 manager star. 30 salesman star. How many salesmen are there? Four. 4 stars. Okay, na? This is created after executing this command. See here, root and intermediate nodes are based on what? Department. Leaf node contains department number and job. The root and intermediate nodes based on department. First field. What is the first field? Department. So and the leaf nodes contains department and job. Okay, then. Understood? Then. So an SQL server uses above index when where condition based on leading column of the index. Leading column of the index. That is first column. First column of the index. That is department number. What that is? Department number. Leading column means first column. What is the first column? Department number. So even your where condition based on department number, then only it will use index. Otherwise, it will not use index. One second. This is my query. Select star from what? Select star from EMP where department number equals to 20. Will it use index? Yes or no? So then read this line. SQL server uses above index when where condition based on leading column of the index, that is first column of the index. What is the first column of the index? Department number. Your where condition based on department, then only it will use index. Here it is based on department. Yes, it will use index. How it will work? 2020 is compared. Go to left side. 2010 is compared. Go to right side. 20 analyst selected. 20 clerk selected. That's all. So take these addresses, go to the table, select the rows from the table. For this query, it will use what, sir? Index. So index can. Okay, this is my query. Select star from what? EMP, where department number equals to 20, job equals to clerk. Then department equals to 20, job equals to clerk. So then what? When you submit this query, then will it use index? Yes. 20 takes the 20. 2020 is compared. Go to left side. 2010 is compared. Go to right side. 20 analyst, but you're asking for 20 clerk. This is 20 clerk? No. 20 clerk? Yes. Then take this addresses. Go to the table, select the records from the table. For this query also, it will use index scan. Okay. Then, so this is my query. Select star from EMP where job equals to clerk. Job equals to clerk. This is my query. Then for this query, it will use index. No. See, here, see, actually, if you want the rows are there in the table. To get the row from the table, you need address. Addresses are there in leaf node. It cannot directly go to the leaf node. It go to the leaf node from root node and intermediate nodes. But using this clerk, can it reach to the leaf node? No. See, you see that bus root and intermediate nodes are based on department number. But given value is what? Job. By using this job, can it reach to the leaf node? No. So it will not use this index. It will go to the table scan. Sir, to use index compulsory where condition should be based on department number. Here it is not based on department. So it cannot reach to the leaf node. To reach the leaf node, compulsory it requires department number. Here department number is not given. Then it will not use index. It will go to the table. Understood or not? Then. Okay, now? Then. That's all. So this is called, what is this is called? Composite index. Sir, here, what is the advantage of composite index? These two queries are taking the advantage of index. Okay, na? Both queries are taking the advantage of what, sir? Index. Where department number equal to 20 and department number equal to 20, job equal to clerk. Both queries are taking the advantage of index. You understood? Then. Sir, if you create only, see, okay, then actually client requirement is there are two queries, is running two queries. This is one query. And what is the another query? Department number equals to 20 and job equals to clerk is running two queries. But what is saying? Both queries are taking, so both queries are running slow. Okay, na? Both queries are what, sir? Running slow. Then. So then you have to improve the performance of both queries. What is the best thing is create index on what? Department number, comma, job. If you create index on department number, comma, job, both queries will take the advantage of index. If you create index on only department, then if you create index on only department number, what happens? If you create index on only department number, only this query will take the advantage of index, but this query will not take the advantage of index. You understood? If we create index on only department number, this query will take the benefit, but this query cannot take the benefit of this index. But if you create index on both, then both queries will take the advantage of index. This is how you decide. So here my where condition is like this. Where what's the first name equal to so and so. Next one, first name equal to so and so. Where first name and what's the first name equal to so and so and last name equal to so and so. Then it is like this. Now tell me what? Both queries are running slow. Then user is saying, Bas, these two queries running slow. Improve the performance of these two queries. Then create index on first name, comma, last name. Create index on first name, comma, last name. Then both queries will take the advantage. So this is how you decide. See, singular, composita, simpler, it depends on where conditions. Here, where conditions based on salary, then create index on salary. Where conditions based on what's sir? Department number and job. Create index on department number, comma, job. That's all. That is how you decide. Okay, then. What is the next one? Unique index. Okay. So what is unique index is? Sir, unique index what? Then does not allow unique index does not allow duplicate values into the column on which index is created. Okay, now unique index does not allow duplicate values into the column on which index is created. On whichever the column you create unique index, into that column duplicates are not allowed. Okay, then what is the meaning? Hmm? Normal index allows duplicates, unique index does not allow duplicates. See the previous examples. You created index on salary. Duplicates are allowed or not allowed? Yeah, you see that. There are two. 3002 na? Yes. Here what sir? 20 clerk 2. 30 salesman 4. Duplicates are allowed? Yes. But unique index does not allow duplicates. Okay, na? Then how to create unique index? Let's see. Okay. Then so how to create unique index? Create what sir? Index, suppose I3 on EMP in brackets E name. Example. But usually unique index is not recommended on E name because E name may contain duplicates. Duplicates are allowed into E name. But just for example, to create unique index, you have to use the keyword unique. You have to use the keyword what sir? Unique. Let's see, create. Okay, now then commands completed. One unique index is created on E name. Then tell me what happens. Whenever boss, when you execute this command, what is created? Tree. What is created? Tree is created. But no, this is based on what field? E name. Then so let's say K. What is this is? K. Suppose then. Okay, na? Left side. Suppose let's say K. K left side. Okay. Then G. G left side. What's that? Adams star. Ellen star. Blake star. G right side. Then G right side. Okay. James star. Jones star. How I am taking? Adams left side G, James right side to G. How I am taking? E name is character field. If it is character field, alphabetical order. Alphabetical order. Next. K right side. Q. Q left side. Suppose Martin star. Miller star. Okay. Next one. Q right side. Then suppose Smith Scott star. Smith star. Understood now? Then so this is how index is created after executing the command. Background in index, it will store the data like this. Alphabetical order. So the names that comes before K will be left side. The names that comes after K will be right side. Q. The names that comes after Q, right side. The names comes that before Q, left side. Okay. Then now I submit a query. What is my query? Select a star from EMP where E name equals to Blake. Then tell me what happens if you write a query like this. First, SQL server checks any index is available on ename. Any index is available on ename. If index is available, go to the index. Index not available, go to the table. Okay. Now index is available on ename. Go to the index. So what is the given name? Blake. Blake is compared with K. Then left side. B is less than K. Go to left side. Blake is compared with G. B is less than G. Then go to the left side. Left side you come to leaf node. Left side you come to the leaf node. Any leaf node is there with name Blake. Adams, no. Ellen, no. Blake, yes. Take this what? Address. Then go to the table. Select the row from the table. That's all. So for this query, it will use what's it? Index. It will use index. Yes or no? Okay, na? Then next. Suppose this is what you are doing. You are inserting. Sorry, you are selecting. You are displaying. Set not display. You are inserting. What? You are what's it? Inserting. Suppose selects are from EMP. You see this? Okay, na? Then. So let's see. Okay, leave it. This is up, low, uppercase, but here in my example, I taken lowercase. No problem because here it is not case sensitive. And then what I'm doing is I'm inserting the record. Insert into EMP NBO, ename, next one, job. Insert into EMP NBO, ename, suppose job, salary, next one, values, number is what's it? Okay, na? Number is what's it? Like 200. Name is what's it? Blake. Name is what's it? Blake. Okay. Then job is something clerk. Salary some 4,000 like this. I'm inserting a new record. Yes. Whenever you insert a new record, this is also inserted into index or not? When I insert a new record, it is also inserted into index. When a new topic is added to textbook, the topic should be there in the index. Similarly, when a new record is inserted into index, that record is also inserted into index. And then first SQL server, it will try to insert this record into index. Blake compared with K, go to left side. Blake compared with G, go to left side. Left side Blake is there. Yes. Already Blake is there. You are trying to insert what's her duplicate. But what is this index is? Unique index. Unique index does not allow duplicates, but you are inserting the duplicates. What this command gives? Error. Understood? Then. So then you are trying to insert what's her duplicate. Okay, then. Understood? So Blake is already there, but you are trying to insert duplicate. Then what is this command gives? This command gives what's her error. Let me run this. Error. Cannot insert duplicate row dbo.emp with unique index i3. It is also specifying unique index i3. Yes or no? Okay, na? This unique index is not allowing a duplicate. That's why this insert is not possible, giving error. Understood? Yeah. So what is the difference between normal index and unique index? Normal index allows duplicates, but unique index does not allow duplicates. Okay, then. Understood now? Then. So the question is, suppose, for example, what are the different methods? What are the different methods to enforce uniqueness? Hmm? What are the different methods to enforce uniqueness? Enforcing uniqueness means not allowing duplicates. What are the different methods to enforce uniqueness? Not allowing the duplicates. One already you know, Bas. What is that is? declare primary key or unique constraint. Yes. When you declare the primary key unique, duplicates are not allowed. What is the second method? Second method is what, sir? Create unique index. There are only two methods to enforce uniqueness. One method is declare the primary key or unique constraint. What is the second method? Create unique index. Understood? Then, and one more point. We don't need to create index on primary key and unique column. No need to create index on primary key and unique column. Why? SQL Server automatically creates index on primary key and unique column. You don't need to create. SQL Server creates. What type of index is created on primary key unique column? Unique index is created. Unique index does not allow duplicate. That is the reason primary key does not allow duplicates. Whenever you declare primary key, what happens background? One unique index is created background. That unique index does not allow duplicate. That is the reason primary key does not allow duplicates. Understood? Then suppose, for example, drop table WhatsApp customer. Suppose create table what? Customer ID integer. This is primary key. Customer name varchar of 10. Customer email ID WhatsApp varchar 20. This is unique. So in this table, I declared a primary key, I declared unique constraint. Now create already. Okay, table name is, let's say, customer. Yes, created. So I created the table. In this table, I taken one field is what? Primary key. One field is unique. Now see, SP help what's her? Customer. Not SP help. SP help will show table structure. SP help what's it? Index. SP help index. It will show indexes. How many indexes are there? 2. Have we created any indexes? No. Automatically created. What are the indexes? One is created on what's that? Customer ID. One is created on email ID. Why? Why they are created? Customer ID is declared as primary key. Email ID is declared as unique. So primary key unique columns automatically indexed. What is the type of index created? Unique index. Here also you see that unique. That is why primary key unique constraints does not allow duplicates. How? With the help of unique index. Okay, na? Then. Sir, actually primary keys, it's not primary key is not allowing duplicates. It is unique index is not allowing duplicates. Understood? Then. So, yeah. Then. Primary key, what's that? Unique columns are what? Automatically indexed by SQL Server. Okay, then. So what is SQL Server creates what's it? Unique index on what? Primary key and unique columns. And unique index what's it? What? Unique index what? Does not allow duplicates. So primary key unique also does not allow duplicates. Primary key unique columns are automatically indexed and SQL Server creates what? Unique index on primary key column. Unique index does not allow duplicates. So primary key also does not allow duplicates. Okay. Then, sir, unique constraint equal to what? Unique index. Understood? Primary key constraint equal to what? Unique index plus not null. That's it. Okay, na? Then unique constraint means unique index. Primary key constraint means Unique index plus not. Okay, na? Uniqueness is enforced only actually one method. What that is? Unique index. Okay, na? But whenever you declare primary key, background, what happens is unique index is created. Okay, then. Understood? Okay, na? That. And up to now, the indexes we created. So three types. You have seen three. What are the three? Simple, composite, unique. So three types. What are these three indexes are called? These three types are called then non-clustered. What are these three are called? Non-clustered. One more is there. What is that is? Cluster. Cluster index. Okay. Clustered index. Then. So what is cluster index is? Okay. Then. So now, sir, here actually non-cluster index is storing what? Non-cluster index is storing what, sir? Address of the actual record. Where is the actual record? Actual record is there in table. That record address is stored in index. But cluster index, the actual record is stored in index. Record is stored in index. Yet there is no table and index is not separate. Table and index is one. Index itself contains row. You understood? Then. So, okay. A non-clustered index stores what? Addresses of actual records. Whereas cluster index stores what's it? Actual records. Okay, na? Then in non-clustered, then in what's it? Non-clustered. Okay. In non-clustered, index in non-clustered, index and table are what's it? Index and table are two separate objects. Table is separate, index is separate. Table contains complete row, index contains only address. But whereas cluster index, table and index are not two separate objects. Table and index are not two separate objects, they're one. Table and index are not two separate objects, they're what's it? One object. Okay, then. So non-cluster index and table are two separate objects, but whereas cluster index, table and index are not two separate objects, they're one object because index itself contains complete row. Okay, then. Understood? Then let's see example. Create table what's it? Customer. Create table customer. Then what is the field? Customer ID. Customer ID integer. Customer name varchar of 10. Enough. Just two fields. Just I'm taking only two fields. Then if table is already there, drop the table. Okay, na? Then drop. So drop table what? Customer. Next. What I'm doing is create what's it? Index. I'll create the index. Create index I10 on customer. What is the table name? Customer. I'm creating index on customer ID. Customer ID. Creating index on customer ID. But what type of index you want to create? Cluster. But if you write command like this, it creates non-cluster. Default is non-cluster. If you want to create cluster index, then just give this. What? Cluster. Okay. Then if you want to create cluster index, then you have to mention clustered. And then what is created is cluster index is created. Now let's see, first create the table. Table is created. Next one, create what's the cluster index created. So table is created. The cluster index is also created. Next, what are the next? Insert. Insert into what? Okay, na? Customer values. Customer, what's that? ID 10. Name is what's that? A. Okay, na? I'm inserting one row. Okay. When you insert, what happens is it is inserted into index. This example, what I'm doing is 50, 30. So this is inserted what's that? Left side to 30. Yes. 10A. Actually created index and customer ID. It should store customer ID. Yes. But it will not only store customer ID, it will store complete row. This complete row stored in index. Are you getting or not? It will actually, whenever you create index and customer ID, it should store only customer IDs. Previous, if you created index on salary, then it shows only salaries. Yes. But the actual card is there in table. But now what? It will not store only customer ID. It store complete row. Okay. Then. So this is one. You insert it. Next one. Suppose I'm inserting another one. Then, sir, here 80, 80B. Then what happens? Let's say, suppose 70. Okay, na? Then where 80 is inserted? Right side to 70, 80B. Yes. Next one. Next one. Suppose what's it? Like, say, suppose 40, 40C. Where 40C is inserted? Left side to 50, right side to 30. Yes. Next one. Suppose, for example, I'm inserting 60D. 60D. Then where 60D is inserted? Left side to 70. 60D. That's okay, no? Then what it is storing? It is storing the complete row. Yes. So it is storing the complete row. Okay, no? Then now suppose I'll create. It's created now. Next, insert. Okay, create now. Yes or no? Okay. Created. It is saying index is created. Next one, insert. I'm inserting 4 rows. The 4 rows are inserted. Yes. Now you submit the query. Select star from customer. And then what? Sir, when you submit select star from customer, then you're asking the data. Where is the data? Data stored in index. It will go to the index. It will go to index. Data is not stored in two places. Index and table. Data is stored in only one. Index. Okay, na? It go to the index. Then and it selects all the nodes starting from left to right. It returns all the nodes starting from left to right. Then go to this one. Go to left side. Selects all the nodes left to right. Because you're asking all the rows now. Then it returns all the rows starting from left to right. Okay. Then. So for this query, then what is this? SQL server goes to what's that? Index and returns all what's that? Leaf nodes starting from left to right. Returns all leaf nodes from left to right. Okay, then. So if you write a query like this, then it goes to then next. Sir, okay now? My query is this. What? Understood? It will not, it will go to the index only because data is there in index. Data is not there in table index. Your table and index is not separate. Table and index is one. Now, suppose select star from what? Customer. Where? So table name is customer. No? Select star from customer. Where customer ID equal to 60. I like select start from. Okay, now first, okay, let me execute this query. Select start from customer. Let me execute this then. Sir, which order you inserted? Which order you inserted? 10, 80, 40, 60. But usually, when you see the table, how it will show the data, whichever the order you inserted, in same order it will display. In whichever the order you inserted the data, in same order it will show. But you insert, which order you inserted? 10, 80, 40, 60. But you see that how it is showing 10, 40, 60, 80. Why? Why? Because it is not getting the data from table, it is getting the data from index. How it is reading? Reading the data from left to right. In left to right, the values are in ascending order. Yes or no? So first to 10, next 40, next 60, next 80. That's all. Left to right. So that means from where it is getting the data, it is getting this data from index. Understood? Then access all the leaf nodes from left to right. Now I'll say select star from customer where customer ID equal to 60. Then select star from customer where customer ID equal to 60. Then what it does, 60, 50 is compared. Then go to right side. 60, 70 is compared. Then go to left side. 60D. Then so then return the row from index. Earlier one, first after finding the 60, take the address, go to the table, select the row from the table. Now it will not do that. Return the row from index only because the row is stored in index. That means how many lookups? Only one. Earlier two, one in index, one in table. Now here only one. Okay, na? Then so then, see SQL server what's it goes to index and what's it finds okay na entry with customer ID equal to 60 and after finding returns row from what's it index not from table earlier table but now index because the record is stored in index so it reduces number of lookups earlier two one in index one in table but yet only one earlier it has to allocate separate memory for table, separate memory for index. But now here what's it? Only one index. Two advantages. One is doesn't need extra storage plus lookups. Only one. Understood, na? That's it. This is the what's clustered and non-clustered. Okay. Understood, na? Then. So that's it. So this is about what's it? Index top. Okay. Then. So with this, these topics are completed. What this is? Actually, we started database objects, tables, views, synonyms, sequences, indexes. They're completed. Next, that's all. We'll start another TSQL. That is programming. Okay, now? Huh? Anything is there, you ask tomorrow. In tomorrow's class, you go through the notes. If anything is not covered, then you can ask. Then after completing that, we'll start TSQL programming. If nothing is there, then we'll start. Okay, now? Then. ఓకే. What? You can go. Hmm. అవును. ఇలానే మనం ఎలా చేసామో అలానే. ఇప్పుడు ఇది 2 సర్వర్‌లా ఇదేమన్నా నేను తీసుకుంది ఇది ఒకే సర్వర్ కదా! ఒకే సర్వరు నంబర్ ఆఫ్ లాగిన్స్ క్రియేట్ చేశాను. అంతే. ఇక్కడ ఎట్లా చేస్తావో అక్కడ కూడా. ఆ! చేయొచ్చు. ఒక లాగిన్‌కి నంబర్ ఆఫ్ యూజర్స్ క్రియేట్ చేయొచ్చు. బట్ నాట్ ఇన్ సేమ్ డేటాబేస్. డిఫరెంట్ డేటాబేస్. ఒక లాగిన్ ఒక డేటాబేస్‌లో ఒక యూజర్ మాత్రమే అసోసియేట్ అవుతాడు. ఒక లాగిన్ ఒక డేటాబేస్‌లో ఒక యూజర్‌కి మాత్రమే కనెక్ట్ అవుతాడు. ఒక లాగిన్‌ని ఒక డేటాబేస్‌లో మల్టిపుల్ యూజర్స్‌కి కనెక్ట్ చేయలేవు. ఓకేనా? దెన్ అంతేగా. అంతే. ఇది మళ్ళీ ఇది వేరు రియల్ టైమ్ వేరు ఉండదు. ఇది. నీకు ఒకటే ఏంటి అంటే టేబుల్స్ మేబీ డిఫరెంట్ ఉండొచ్చు. ఇప్పుడు నేను ఎంప్లాయీ టేబుల్ ఏదో తీసుకుంటున్నాను. ఎందుకంటే కాన్సెప్ట్స్ ఎక్స్‌ప్లెయిన్ చేయడానికి. నువ్వు నీ ప్రాజెక్ట్‌కి సంబంధించిన టేబుల్స్ యూజ్ చేస్తావు. మేబీ బ్యాంకింగ్ అనుకో, బ్యాంకింగ్ ప్రాజెక్ట్స్ ఉంటాయి. ఆ టేబుల్స్ యూజ్ చేస్తావు. అది డిఫరెన్స్ వస్తది. బట్ చెప్పే కాన్సెప్ట్ అన్నీ సేమ్ ఉంటాయి. హ్మ్. అంతే. అంతే. హ్మ్. ఆ! కాంపోజిట్ ఇండెక్స్‌లో మల్టిపుల్ కాలమ్స్ ఇవ్వచ్చు. నేను 2 తీసుకున్నాను. 3 ఇవ్వచ్చు.